Then let's begin by learning how to solve a system by graphing. There are different methods for solving a system of linear equations. In this video, we will solve the system by graphing all equations in the same coordinate plane and finding where they intersect, the point they have in common. In example 2, the equations are written in slope-intercept form. Then let's find the slope and y-intercept for each, graph them, and find the solution, the point where they meet. Recall in the video for graphing linear equations, the slope-intercept form was given by y equals mx plus b, where m represents the slope and b represents the y-intercept. So let's start with the first equation. Our first equation in the system is y equals negative 3 over 2 x minus 7. For this one then, our slope is negative 3 over 2 and our y-intercept is negative 7. When we are graphing linear equations, we always graph b first. So since b is negative 7, we're going to go to the y-axis and plot the point at negative 7. Once the y-intercept is plotted, we're going to use the slope to find the next point. Now notice how the slope in this first equation is negative 3 over 2. It doesn't matter who you give the negative to. You can give the negative to the numerator or you can give the negative to the denominator as long as you don't give it to both. That means that the slope could be negative 3 over 2 or it could be 3 over negative 2. You might be asking, what's the difference? Well, if we have negative 3 over 2, that means that our rise is negative 3, so we're going to move 3 down. And our run is positive 2, that means that we're going to move 2 to the right. So let's plot a point in that direction. From the y-intercept, I go 1, 2, 3 down, and then 1, 2 to the right. And that's where the second point will be located. However, if I use 3 over negative 2, that means that I'm going to go 3 up and 2 to the left. So from the y-intercept, again, I go 3 up and 2 to the left. And that's where we plot our other point. Regardless of which one you use, the negative 3 over 2 or the 3 over negative 2, when we connect the points, they will all line up in the same line. So let's graph the line. Now that we have a first equation graph, let's bring the second. This is y is equal to x over 2 plus 1. You see how in a second equation, the x doesn't have a written coefficient? We're going to rewrite it so that it can help us with the slope. So then this will become y is equal to, well, if you have an x, that means that you have 1 x's. So this will be 1x over 2 plus 1. So this will become our slope, and this our y-intercept. Remember, we always plot the y-intercept first. So let's do that. On the y-axis, we plot our y-intercept, which is positive 1. Then we're going to use the slope to find our next point. In this case, the slope is 1/2. That means that the rise is 1. We're going to move 1 up. And the run is 2. We're going to move 2 to the right. So let's do that. From our y-intercept, we move 1 up and then 2 to the side. And that's where we plot our next point. Now, because this is the slope of the entire line, we can continue to move 1 up and 2 to the side to find a third point and a fourth point and a fifth point, as long as we continue to move one up and two to the right. Now you might be asking, why do we want to plot more than 2 points? Well, we want to be precise to make sure that the point that we find to be the intersection is actually the correct one. So let's plot this second line. Now once we have both equations graphed, we're going to notice that this is a point where they intersect. This is a point where they meet the point they have in common, that is -4, -1. This is telling us that -4, -1 is the solution to the system. This means if we were to plug in -4, -1 into both equations, just like we did in example 1, we will get a true statement for both of them. So let's try another example. Now, in example 3, they're still asking us to solve the system by graphing, but now our system is written in standard form. If you recall from the video finding slope and graphing equations, the standard form is given by ax plus by is equal to c, and the slope is found by dividing -a over b. That means that we have to change the sign of a, and the y-intercept is found by dividing c over b. So let's bring our first equation. The first equation is -7x plus y is equal to -8. Because y doesn't have a coefficient, I'm going to write a 1 to help me find a, b, and c. Now we have it. A is equal to -7, b is equal to 1, and c is equal to 8. So let's start. First, we need to find our y-intercept. So b is found by dividing c over b. That is -8 over 1. Well, 8 divided by 1 is 8, and because they have different signs, this will be -8. So we plot our y-intercept on the y-axis passing at -8. Here's a y-intercept. The next thing to find is the slope. The slope is going to help us find that next point. The slope is found by doing -a over b. Now there is a negative in the formula, and then a itself, it's a negative. And b was 1. Because we have this minus negative, or the negative, that's going to turn into a +7 over 1. And I'm not going to simplify the fraction. Since the slope is rise over run, I'm going to leave it as 7 over 1. For us, this means that the rise is 7, so I'm going to move 7 up from the y-intercept, and the run is 1, so I'm going to move 1 to the right. So let's plot that. I'm going to move 7 up, that's 1, 2, 3, 4, 5, 6, 7, and then 1 to the side, and that's where I plot my second point. Remember, because the slope is the same throughout the line, you don't have to stop at 2 points. You can continue to use the slope to find a third point or a fourth point. The more points that you plot, the more precise your line is going to be. So I'm going to plot another point by moving again 7 up, and then 1 to the side. And that should be enough for my line. Let's graph it. Now that we've graphed our first equation, let's take the second one. This is 3x minus 3y is equal to -12. Let's find a, b, and c. In this case, a is 3, b is -3. Right here, here's a, here's b, and c is that -12 on the other side of the equal sign. We first find our y-intercept, and that's by dividing c over b. So that makes it negative 12 divided by negative 3. So 12 divided by 3 is going to equal 4, and the negative negative will make that a positive. So let's plot our y-intercept at positive 4. Next, we're going to find the slope so we can find another point, or maybe a third point or a fourth point, so that we can graph this equation. And the slope is given by negative a over b, so that would be negative 3 divided by that negative 3. What happens if you decide to divide it? So negative 3 divided by negative 3 is going to equal to 1. But because we need a rise over run, the way that you make a whole number of fraction is by dividing by 1. For us, this means that the rise is 1, so we're going to move 1 up. And the run is 1, so we're going to move 1 to the right. So from the y-intercept, we're going to go 1 up and 1 to the right, and then 1 up and 1 to the right, and then 1 up and 1 to the right. And it's really up to you how many points you want to plot. Remember, the more points you plot, the more precise your graph will be. So now that we have the points, let's graph our line. With both our equations graphed, we see that the point of intersection is located up here in quadrant 1 at 2, 6. Then 2, 6 becomes the solution to the system. Notice how in example 2 and even here in example 3 have the y-intercept as whole numbers. This is one of the drawbacks for this method. First, you have to be very precise when you plot and graph the lines, or you might end up with the incorrect point of intersection. One way to avoid this is to use the slope more than once and plot several points, just like I did. And the other is that if the y-intercepts are fractions, you're going to have to use a different method to graph these lines, like plotting points. I recommend that you watch the video on graphing linear equations for additional graphing methods.
Thank you so much for watching, and I'll see you in the next one.